Hi, this is a video which describes the effect of using the equation y equals mx plus c. So y equals mx plus c is an equation which describes a straight line or a group of straight lines. And you'll see right throughout this video that basically everything we do is we'll type in equations of the form y equals mx plus c, and in each instance we will get a straight line, albeit that straight line varies. Perhaps the simplest and most easy of our equations is y equals x. And if I put that in and press return, you can see a diagonal line running from the bottom left to the top right of the screen. So we say that this has a gradient of 1. What we can then do is we can experiment to see what happens if I was to vary that value of the number in front of the x. So at this stage, that number in there where the cursor is flashing here is a 1. What happens if I was to change that to a 2? And you can see that my line increases in its gradient. That is, it gets steeper. To confirm that in fact this is what's happening, I can put 3. And again, now my red line is increased further. All of those lines are still passing through the origin. All that's happening though is that we're getting steeper and steeper gradients as we're increasing that value of the number in front of x, our coefficient of x. So what would happen if I put a negative coefficient in? So let's try it. So a negative there, and you can see equally a steeper line, but this time it's travelling downhill. So the red line was our y equals 3x, the blue line y equals negative 3x. So it's equally as steep, but as I said, travelling downhill rather than uphill. If I was to get rid of the 3 and just leave it as y equals negative x, and put it in there, you can see again here our y equals negative x line, and if I click on that purple line, that's our y equals x line. Again, the gradients appear to be roughly the same. It's just with the positive gradient we appear to be going uphill with our gradient, where a negative number will give us a downhill slope. So perhaps one of the biggest, or two of the biggest things that we can point out is that the gradient is determined by the number in front of our x, and that if it's a negative we get a downhill, if it is a positive we get an uphill slope. If it is a larger number, so for instance a 3, and I'm ignoring the fact it might be a negative 3, but that would indicate that it's relatively steep, whether it's in the negative or positive way. The bigger that number, the steeper it is. So for instance, if I put 0.2x as it's a relatively small positive number, I'd expect a gradient which is sloping uphill, but not terribly quickly. And you can see that's exactly what occurs. So if we clear all those now and refresh our screen, I'll just put y equals x back in. That's, as I said, a good way to actually have a comparator, almost like a control in a scientific experiment. So this we're going to compare to. Here, so I've got y equals x. If I was to change the number afterwards, and this time I'm going to add to it, whereas with the coefficient I was playing around with previously, that was multiplying by x. But here we're going to add or subtract a number. So if I said y equals x plus 0, you can see I'm still passing through the origin. My gradient hasn't changed at all. And the fact that I had y equals x or y equals x plus 0 didn't seem to make any difference. But what about if I was to change that 0 to a 1? And you can see now that I've actually moved my graph up. It's still got the same gradient, which shouldn't surprise me because the number in front of the x hasn't changed, so the slope shouldn't have changed. What has happened though is that I've shifted the blue line to where the pink is by shifting it effectively up 1. So if I put in a plus 2 there, what might happen? Well, as you might anticipate, our gradient is still the same because the value in front of the x hasn't changed. But this time, from my original y equals x plus 0, I've now shifted it up 2 points to y equals x plus 2. And if I was to change that to a take away 2, so y equals x take 2, you can see that this red line here shows what's happening. And it's actually been shifted down from my original 2 points. So y equals y equals x minus 2, we'll actually shift our gradient down. So in summarising with this here, if we were to change the number at the back to the right of the x by either adding or subtracting, we'll either raise the graph up or lower it down, and we call this translation. So we will translate it up in the y-axis or down in the y-axis, but it's a translation, upwards or downwards. So in summary for all of this video, two numbers that we can play with. There's a number which precedes the x and multiplies by it, and that will affect the gradient. If it's a positive number, it will be an uphill gradient. A negative number will give a downhill gradient. The larger the number, the steeper the gradient. If we were to adjust the number at the back of or that follows after the x, that's actually affecting how far our graph is moved downwards or upwards. So if we were to add a number, our graph moves upwards and is translated upwards. Moving it downwards would mean that we're subtracting that number. And the size of the number will indicate what we call our y-intercept. So you can see that our graphs always cut the y-axis, which is this one here, always cut that y-axis at the value as indicated here. So that's the y-intercept's -2 for y equals x minus 2. If I was to click on this purple graph, you see my equation changes, y equals x plus 1. So my y-intercept is 1. And indeed, you can see that that's where it's cutting the y-axis. So quite a lot of information here. You might like to replay this in parts to see if you can just consolidate your understanding. Thanks for listening.